AP Calculus AB, we're looking at the fundamental theorem of calculus and particle motion, and this video is going to focus on applying this analytically. The velocity of a particle that is moving along the x-axis is given by the function v of t equals 0.5 e to the t times 2 minus t cubed. This is a calculator active question. At this point, we have no idea how to integrate this. That's why we need our calculator. If the position of the particle at t equals 1.5 is 2.551, now that's an ordered pair. So I'm going to write that down. I'm going to use p for my position. So the position at 1.5 equals 2.551. What is the position when t equals 3.5? This is asking us to find p of 3.5. Using the fundamental theorem of calculus, if we integrate the velocity function, which is 0.5 e to the t times t minus 2 cubed, with mad props to t, this should equal the position of the function at some time minus the position of the function at some time. Now, since we know 1.5 is the time and this is the position, and we're trying to find the position at time 3.5, we want to integrate this from 1.5 to 3.5. According to the fundamental theorem of calculus, this is going to be equal to the position of the function at 3.5 minus the position of the function at 1.5. Using a calculator, we are going to integrate this, and I encourage you to stop the video and use your calculator. I got 15.919. We don't know what the position is at 3.5. At 1.5, the position is 2.551 because we are told that right here. Using some algebra, add this to both sides, and we get 18.470. The position of the particle at 3.5 is 18.470. We have no idea what kind of units we're in. B, what's the total distance the object travels on the interval? Total distance, we have to take the absolute value of the velocity function. And once again, we don't know how to integrate this. We don't know how to integrate products. So we use our calculator for this also. To find the absolute value bars, you go to, I think it's math, and then numbers, and then ABS, absolute value. So integrate this with your calculator. If you forget how to do it, let me know, and I'll remind you how to do it. Send me a message on Remind, or ask me in school. You get 913.067. All right, let's check out a second one. The velocity of a particle that is moving along the x-axis is given by the function v of t equals 3t squared plus 6. This is a non-calculator active question, so we should be able to figure this out without a calculator. If the position of the particle at t equals 4 is 72, that means the position at 4 is 72. What's the position? So find the position when t is 2. That's what we're trying to find. Fundamental theorem of calculus. If we integrate from 2 to 4, and we're using 2 and 4 because those are the two times that we're given, the velocity function, we should get the position at 4 minus the position at 2. This is not work you would have to necessarily show. I'm just emphasizing that's what we're doing. So our function for velocity is 3t squared plus 6. That's something we can easily integrate. And the position at 4 is 72. The position at 2, we don't know. This is 72. That's how we know that. Integrating 3t squared, you're going to get t cubed. Integrating 6, you're going to get 6t. have to evaluate this from 2 to 4. So we're going to put 4 in for t and subtract from that. Put 2 in for t. Four cubed is 64. 6 times 4 is 24. 2 cubed is 8. 6 times 2 is 20. So this is going to give us 40 minus, I'm sorry, I made a mistake right here. This is a plus sign. It should be a plus. That's going to give us 88 minus 20. So that's going to be 68. If we subtract 72 from both sides, we get negative 4 is negative p of 2. Therefore, p of 2 is going to be 4. B, what's the total distance the particle travels from the interval from 0 to 7? Total distance is equal to the absolute value of the velocity function from whatever a and b are. Well, in this case, a and b are 7 and 0, 0 and 7 I should say. The velocity function is 3t squared plus 6. Now, how do you integrate an absolute value? You integrate it as if the absolute value wasn't there. So this is going to be t cubed plus 6t evaluated from 0 to 7. So we're going to have 7 cubed plus 6 times 7. Take the absolute value of that. And then we're going to subtract from that 0 cubed plus 6 times 0. Now obviously this part here is all going to be 0. 7 cubed is 343. 6 times 7 is 42. And this is just going to be 0. That's going to give us 385. The absolute value of 385 is 385. So there we go. Total distance from 0 to 7 units. It doesn't tell us what kind of units we're in. It's 385 linear units, whatever that is. So there's your couple examples for looking at this analytically. And we're going to have 2 more videos for this. One looking at this graphically, and another checking this out, looking at tables.